Okay, this video is going to deal with if structure. It's chapter 5, if structure. We're going to introduce it here, and we're going to be on page 2 of our chapter 5 notes in the middle. And so if structure is a word that will, as we go on in today's video, you're going to see more what if structure means. But we're going to first of all take a look at it. This is a single alternative if, which will make more sense later as we go along. Let's say we have a program here whose purpose is to calculate the test score. And so we have a we're going to declare a variable called points earned, and so we'll keep track of our memory location, which would be important, points earned, and we are going to get input from the user on that. And then we also have the next line is a named constant who has a value already. So points possible has a an amount of 50.0. Oh, that's too big. Alright, so it has a value of 50.0, and that's how many points are possible. And so when we get the user to enter how many points was earned on the test, then we're going to have the computer calculate the percentage. And so we ask the user right here for the points earned, and let's just say that they enter, let's say they say 40. Alright, so if they say 40, they got 40 out of 50, then we can all do the math, but you're going to have to program the computer to do the math. So we're going to put whatever the percentage is into a variable called percentage. And so what's going to happen here is on this line, it's declaring percentage right here, and it's assigning the calculation, or the result of this calculation, which is points earned. So this is a variable call. It calls points earned, which is 40, and it's dividing by 50, which 50.0, which is this memory location, and so multiplying by 100, and then it stores the result, which is 80.0 in this variable or memory location right here. Now here's where we come into the if structure. The if structure starts right here, and it's going to go all the way to here. And in this if structure, you see it says if the percentage is greater than or equal to 70. So percentage, of course, is a variable call. And it's asking, it's calling percentage, going, what is your value? And so percentage value, or variable, returns the 80.0 to here. And now, as we had talked about in Boolean expressions, which is what this is a Boolean expression. Percentage is greater than or equal to 70. It's using a relational or comparison operator, and it's comparing two things, the value of percentage and 70. And so 80.0 is greater than or equal to 70, which is true. And remember, we said that a Boolean expression is always going to be evaluated to be true or false. And of course, in this case, it's true. Now, because it's true, the compiler is going to jump inside these curly braces and start doing the program statements in here. And so it prints out, congratulations, you passed with a percentage of, and then it calls percentage, and that returns an 80.0. So that's going to be printed on the screen because of the variable call. And so it's going to say, congratulations, you passed with a percentage of 80. Now you can see how that actually makes sense, okay? Is because it's a passing grade. And then it says, you may now begin the next chapter. And once it's done here, it jumps out of those and prints this statement right here, system.out.println. Thank you for using this program. So now we're going to look at this in Java, and if you want to open up Java and follow along with that, you can in JGrasp. It's the if structure demo.java in the module for today. or you can just watch. And so the point here is that we know that if it's 40 points, that the percentage is going to be 80.0, and 80.0 is true, makes the sentence true. So 80.0 is greater than 70, and so it's going to print all this. So if we run this, if we compile it and then run it, and we enter a 40, then you can see down here it says, congratulations, you passed with a percentage of 80.0. You may now begin the next chapter. Thank you for using this program. Okay, but what happens if they enter, the user enters 30 points? So what should happen here is if they enter 30, the percentage is going to end up being 60.0. And so when 60% is called, it's 60.0. Well, 60.0, this is a Boolean expression. Is this a true statement? So that's what the evaluation is made for Boolean expressions. This is a false statement. So since it's false, if you think about it, what would it do? It's going to skip these lines in here and go directly to the line after the set of braces. And so it should, after asking for the points earned and the user entering that, it's going to do the calculation. It's going to come here and evaluate this to be false, and then it's going to go and just print thank you for using this program. So let's see if that in fact works. So here's our compiling. Here we run it, and so we enter how many points? We enter 30, and then notice it says thank you for using this program. So it totally skipped the congratulations and all that kind of stuff that's in these two lines of code. Alright, so well, what if we do 35? 35 points gives a 70, whoops, it gives a 70%. And so if you have a 70% in here, the question is, if you enter a 35, then what's going to happen here is the percentage is going to be 70.0. And so the question is here, is 70.0 greater than or equal to 70? And of course it is. And so because of the equal sign, it says 70.0 is equal to 70. Alright, so because it is true, then it should go in here and print congratulations, because 70 is a passing score. We said greater than or equal to 70. And so when we run the program, then it goes, we type a 35, which is going to give us 70%, and then it says congratulations, you passed, and you may now begin the next chapter, etc., etc. So that works. Alright, so that's how that works. And now let's look at the next thing. Let's look at one more thing here. Let's say that we remove the equal sign and we run it again and we type in a 35. Notice how down here now it skipped these lines of code. Alright, so what that's saying is that 70 is not a passing score. And so if you want 70 to be part of the passing score, then you have to say or equal to. Now, if you don't want to use an or equal to sign, what could you, if you just wanted to say greater than, what would you change 70 to make a 70 actually be a passing score? And that would be 69. So if you said greater than 69, then that means a 70 is greater than 69. That's true. So now it would go in here and actually print those statements. So we'll do 35, and now it says congratulations, you passed with a percentage of 70.0. So those are things that can take place. And let's pause for a second. Now let's look at our notes, chapter 3, or page 3, and let's do some labeling. So, it says here here's our code. Here's our if structure. We want to label. So on your notes, you're going to label the if structure, terms, and concepts. So the if statement, everybody should know what that is just by looking at it. So this, of course, this whole thing is the if statement. An if an if statement has the word if in it, and then it has this right inside the parentheses, and that's called a Boolean expression. So that would be Boolean expression is inside the parentheses. It's Boolean because it has a comparison operators and is comparing two things. So an if statement has an if, the word if, and it has a Boolean expression within parentheses. It also, the if structure has the beginning and ending curly braces, which we've been using all along in our class as it relates to class headers and method headers. And then it's got an if clause. Well, the if clause is just all the statements in between the two curly braces. So you might have just one line of code, you could have 2 lines of code, you could have 7 lines of code, you can do whatever inside here, which is the if clause. Now an if structure is used only if there is one alternative. Only one alternative. So all we want to say in this program here is we want to congratulate them if they get a passing score. If they don't get a passing score, we're not going to do anything. So the only alternative is to congratulate them for passing. So all we need to use is an if structure. This will make more sense as we go along. Multiple alternatives will require an if-else structure. So down here, you're going to write if-else, and you write if-else with 2 dots in between the if and the else, just like down here. So if we want to have more than one alternative. Now, if you think about this, what alternative could we add to our example, making it necessary to use an if-else structure? How do we create another alternative? So if you want to think about that, you pause the video and think about it. The idea here is if we say, we could say one alternative would be if they get a passing score, we say congratulations. If they get a failing score, we say, sorry, you did not pass the test. You will need to retake the test. That's our second alternative, is what to say if they didn't get a passing score. So there's 2 alternatives that will require an if-else structure, which we'll learn later on. If the Boolean expression of the if statement is true, what is executed? Well, these sentences, these lines of code, and those lines of code are if clauses. The if clause is executed. If the Boolean expression of the if statement is false, the if clause is, and as we showed in our program earlier, that like for instance here, up here, let's say here's the 30 produces 60%, which made this statement up here false, and so notice it skipped everything up until the very sentence after the if structure and just says thank you for using this program. So these lines of code, the if clause, was ignored. So you can say the if clause is ignored, it's skipped, and the compiler goes to the first line after the if structure. And so that's what we showed in the other program. It went in and said thank you for using this program. So the next thing here is if the Boolean expression, oh wait, we did that. If the if structure begins with the if statement and it ends with the ending curly brace or the closing curly brace. All right, and so the if structure begins with the if statement and goes to the ending curly brace. This whole thing is considered the if structure. Okay, so now before we continue on with the rest of the notes, we're going to go back to the program. We're going to demonstrate something and then fill in some more notes. So the question here is, what if we take or remove these braces? What happens if the programmer doesn't include these braces? Is there a time when you might not include the braces on purpose? Well, here's what happens. Let's say that we're going to do we're going to type the 30 as the user input again, which gives a failing grade or a not passing grade. So what will happen is, as we showed already, when it comes to here, it's going to skip the if clause. Now the if clause is these two statements. So what it did before is it skipped these two statements and went directly to thank you for using this program. What happens if we remove the braces? And so let's take a look. We're going to compile it, and the compiler didn't mind the braces being gone. And now we're going to run it. And so enter the points in, earned, it's just 30. And notice then it prints, you may now begin the next chapter, and thank you for using this program. So it said, okay, this is false. So since it's false, then we skip the if clause. Well, it didn't skip, you may now begin the next chapter. It went ahead and printed that. Here's why. What happens is, if there are no braces, then the if clause is only the next statement or the next line of code. The compiler will recognize only the next one line of code as the if clause. It would be as if you were only putting in curly braces around one line of code. So not having any braces is the same as putting curly braces around only the next line of code. Oops. That's what that means. And so you can, okay, so let's go back to our notes then. So curly braces are optional if there is only one line of code. So if there's only one line of code, you don't really need the braces, because it's the compiler is going to automatically recognize that next line as being the if clause, just like we showed. But without curly braces, the compiler considers only the next one line of code to be the if clause. Okay, so that's what we just demonstrated. Now curly braces are required with multiple lines of code in the if clause. So as we showed here, if we wanted to say, you may now begin the next chapter, along with, congratulations, you have a passing score, then, then we have to put the curly braces around both statements if we want more than one line to be the if clause. So as we go back then, now some programmers always use curly braces. They just use them all the time. Now for me, I prefer using braces all the time because it's easier to read, and it sets the boundaries more clearly. So in this class, let's always use curly braces, even though we don't have to. Now we're going to practice reading code that does not use curly braces. So, but when we go ahead and make our own programs, let's use curly braces, even if there's only one line of code in the if clause. The other thing is, we need to check one more thing, and that is what happens if we put a semicolon at the end of an if statement. And this is something I don't have on your notes, but this is something you should add to your notes. Nothing. And so we run it. It's supposed to do something. Oh, that's weird. I don't know why that worked. No, it didn't work. It actually didn't work because it says congratulations, you passed with a percentage of 60.0. So without the semicolon, which is the correct way to do it, then when we put that 30 in there, then it correctly skips the if clause and says thank you for using this program. Alright, so that's a reason why we do need to leave off the semicolon. Pay attention to indentation. So as you notice here, the indentation here, the if statement is in line with the other statements that have been indented within the main method. But then there's indentation, the if clause is indented. So that's the key thing, the if clause is indented. And then finally, we test code by testing each possibility. I'm sorry, let's say that again. We test code by testing each type of possibility in regard to the Boolean expression. And we already did this up here. Here's the Boolean expression. If it's greater than or equal to 70, then it does this if clause. So what we did is we picked, okay, well let's pick a value that's going to make this true or greater than or equal to 70. So we did a 40 because that made the percentage 80, so it's higher. Then we picked one that was exactly the same. So you not only have a greater than 70, you have an equal to 70. That's another type of possibility. Well, you also have values that are going to be less than 70. So we typed a 30 points possible, or 30 points earned, so that it would give an amount that's less than 70. Alright, so we tested each type of possibility to make sure the program was giving the correct output in each situation. Alright, so that is it as far as your notes for page 3 of the chapter 5 notes.